Good day. Welcome to the third part of our discussion video on power series and their convergence. Before watching this video, make sure na napanood niyo na yung second video ng ating discussion class. Again, katulad ng sinabi ko sa first and second part, our goal is to find the radius and interval of convergence of the given power series. We have here 10 items to answer, 6 of which are exercises given in page 62 of Math 22 module. So far, we are able to answer items 1 to 5, and during our second video, I left number 6 as an activity. So I hope na before watching this video, sinagutan niyo talaga yung number 6 na binigay ko last time. Okay? Tignan natin kung parehas ba tayo ng conclusion na nakuha. For number 6, we have the following infinite series. As you observe, yung absolute, as you observe, the exponent of x here is 1. So x is independent of n. If that is the case, we can factor out x out of the summation. So this is just equal to x times this infinite series. If it turned out that this infinite series is convergent, then we say that the product of these two is also convergent, since x is just any real number. If ever this infinite series turned out to be divergent, then as you multiply any real number, the resulting infinite series also diverges. So what we have to do is to check whether this infinite series converges or diverges. As you can see, our n here ranges from 1 to positive infinity. Thus, each term in this infinite series is non-zero. Since each term in this infinite series is non-zero, we can apply the ratio test. No? Let's call each term in this infinite series as a sub n. So let a sub n be equal to this one for all n. We now try to apply the ratio test since each term in this infinite series is non-zero. As we apply the ratio test, we have to look for the limit of the absolute value of a sub n plus 1 over a sub n as n goes to positive infinity. Replacing values for a sub n plus 1 and a sub n, we'll get the following. So this is your a sub n plus 1. This is your reciprocal of a sub n. The absolute value of negative 1 raised to n plus 1 is just 1, as well as negative 1 raised to n. N plus 1 factorial is just n times n. It's just n plus 1 times n factorial. So n factorial in the numerator and the denominator will cancel out. What will be left to us is the absolute value of n plus 2 over n plus 1 times n plus 1. Since our n here ranges from 1 to positive infinity, the absolute value of the 1 inside will be itself. So this will just be the limit of n plus 2 over n plus 1 times n plus 1 as n goes to positive infinity. As you evaluate this limit, you'll get 0, which we know to be less than 1. Therefore, this infinite series converges absolutely by ratio test. Since we know that this infinite series converges, as you multiply any real number x to that infinite series, the resulting infinite series will also converge. So, in other words, this infinite series converges for any real number x. If that is the case, then your radius of convergence must be infinity, and your interval of convergence must be the real number line. So this is your answer for number 6. Parehas pa tayo ng nakuwang sagot? I hope so. Let's proceed with number 7. We have the following. We have this infinite series. As you consider any value for n factorial times x minus 2 will be non-zero only if you consider values for x that is different from the center. First, let us call each term in this infinite series to be a sub n, so that a sub n be equal to this one for all n. Sabi natin, we wanted to apply the ratio test, and we can only apply the ratio test only when each term in the infinite series is non-zero. This will be non-zero for all values of x that is different from the center. So we exclude 2 before applying the ratio test. Taking the limit of this one as n goes to positive infinity, we'll get the following. So this is your a sub n plus 1, this is your a sub n. N plus 1 factorial is just n plus 1 times n factorial. So n factorial will be cancelled out from the numerator and the denominator. X minus 2 raised to n plus 1 over x minus 2 raised to n. So magka-cancel out yung x minus 2 raised to n, yung matitira pang absolute value ni x minus 2. So meron ka natirang n plus 1 times x minus 2. X minus 2 is independent of n, so you can factor that out. You'll have the absolute value of x minus 2 times the limit of n plus 1. The absolute value of n plus 1 here is itself, since our n ranges from 0 to positive infinity. Kaya naging limit of n plus 1 na lang. The limit of n plus 1 as n goes to positive infinity, this we know to be positive infinity times a positive number. We have here positive infinity. Thus, if you consider any real number that is different from 2, your infinite series will diverge by the ratio test. Again, if you consider any real number for x that is different from 2, your infinite series will diverge by the ratio test. Now recall that every power series is convergent at its center. So in return, this infinite series converges when x is equal to 2, which is your center. Therefore, your radius of convergence must be 0, and your interval of convergence is the set containing your center. And this is our conclusion for number 7. For number 8, we have the following. Let's call each term in this infinite series a sub n. So let a sub n be equal to this one for all n. We wanted to apply the ratio test, so we have to make sure that each term in the infinite series is non-zero before applying the ratio test. Notice that each term in this infinite series will always be non-zero whenever you consider x that is different from the center. So we exclude the center before applying the ratio test. For all x that is different from the center, we take the limit of this one as n goes to positive infinity. Replacing values for a sub n plus 1 and a sub n, we get the following. So x minus 3 raised to n plus 1 over x minus 3 raised to n is just x minus 3. So you can factor out x minus, you can factor out x minus, absolute value of x minus 3. And you will be left with the following. N plus 1 times n plus 1 raised to n is just n plus 1 raised to n plus 1. And then we have here n raised to n. We know that n ranges from 1 to positive infinity, so the one inside the absolute value is itself. Now, the limit of n plus 1 as n goes to positive infinity, this we know to be positive infinity. For the limit for the limit of n plus 1 over n raised to n as n goes to positive infinity, verify that this is equal to e. So apply your Math 21 skills for this one. Di na natin ito isusolve. Okay? Verify that this limit is equal to e. If that is the case, then we have here positive number times positive infinity times positive number. This is just positive infinity. Thus, this means that if you consider any real number that is different from the center, the infinite series of a sub n diverges for all x satisfying this criteria. Again, if you consider any value for x that is different from the center, your infinite series diverges by the ratio test. Now recall that every power series is convergent at its center. So this infinite series is convergent at x equals 3. Since this infinite series diverges for all x that is different from 3, and it converges when x is equal to 3, we say that its radius of convergence is 0, and its interval of convergence is the set containing the center. And this is our conclusion for number E. So far, among the 10 items that we have given, we are able to answer items 1 to 8. So we are left with items 9 and 10. I will leave this as an exercise for you. So you try to look for the radius of convergence and interval of convergence of these two. I will leave this as an exercise. For number 9, verify that its radius of convergence is 0 and its interval of convergence is the set containing the center. Verify that this is true. For number 10, verify that the radius of convergence is 1/3 and its interval of convergence is given by the following interval. So verify. That's all for today's discussion, class. Thank you for watching and see you in the future discussion videos.